Hello, my student. Yes, it's me again, Madam Gracious Kanzini from Educare Tanzania. My student, I hope you're doing well. Welcome for our chemistry session series. And my Form 4 student, we are proceeding with our topic, which is nanometal and their compound. In this topic, we have a lot of subtopics, but it is so amazing that in previous session we have started our first lesson and also we proceed with the second lesson, but today we are proceeding with our series where we are going to continue with another subtopic, which is for chlorine. Now, my student, let us start with the chlorine. What is the chlorine and why we are studying chlorine in this topic? We have already try to pass through the concepts and the introduction for our topic. So the chlorine is our first nanometal where we are going to discuss it, and we are going to see also their compound. So because our topic is all about nanometals and their compound, so we are going to start with chlorine, which is a nanometal, and also we are going to see their compound related to this nanometal. Now, chlorine exists as a diatomic gas molecule. Chlorine exists as a diatomic gas molecule ambayo tunaona kwamba inakuwa ni chlorine gas. It is a group 7 and period 2 element of the periodic table. Kwenye periodic table huyu chlorine ana exist katika group number 7 ambapo tunaziita ni halogen, halogen group. Lakini ukija kwenye zile horizontal rows of the periodic table, yenyewe chlorine ina exist katika period number 2. So it is atomic number is 11. 17, kwamba atomic number yake ni 17, and it has an electronic configuration of 2:8:7. I hope my Form 4 students, you are aware about electronic configuration, how to write it, and I hope here you are not wondering anything. So the chlorine have the 3 shells, whereby we have the first inner shell, which have the maximum of 2 electrons. That's why we see here 2 electrons. But also the second cell, which is fulfilled with 8 electrons, as you see, 2:8. But the outermost shell, which is the third shell, in the electronic configuration, it have them 7 electron. So as this electronic configuration, it make the full number of electrons, or the atomic number of chlorine, which is 17. Now, chlorine is a very reactive element and the second strongest oxidizing agent among the halogens after fluorine. Tuliona kwenye oxidizing power of these nanometals kwamba the one amongst of the characteristic or properties of these nanometals is their oxidizing power, the way they can able to oxidize the compound, the element. So chlorine ni very strong oxidizing agent, na pia vile vile ni second oxidizing agent after chlorine, kwa sababu tuliona kwenye ile series ya ile group 7 element or halogen compound, tuliona kwamba anaanza fluorine then anafuata chlorine. So kumbe akitoka fluorine ambayo ni first, anakuja chlorine. So chlorine ni very strong oxidizing agent ambayo ni second oxidizing agent katika ile series ambayo tuliona kwenye session iliyopita. Now, chlorine gas is a greenish yellow in color and exists in nature in the combination with other elements in form of chlorides. Kwamba chlorine mwenyewe ni greenish yellow in color, kwamba rangi yake is like greenish yellow. Greenish yellow means that kijani kinaendea kwenye njano, so at the intermediate there. So that's why we say it greenish yellow color. But also ina exist the way inavyo exist katika ile natural way yake, ina exist katika combination ya other element ambapo ina exist kama chloride. Ndio maana tunaona sodium chloride, potassium chloride and so forth. So hai exist kama chlorine, no. Ikiwa na compound nyingine, ikiwa imeform combination of 2 or more elements, tunaiona ina exist kama chloride. Now Sodium chloride is the main sources of chlorine in most industrial processes. Kwamba kumbe sodium chloride ni main sources ambapo tunaweza tukapata this existence nature of chlorine katika industrial processes. Chlorine gas is the extremely poisonous and it is the first poisonous gas that was used during the First World War in 1916. Kwamba chlorine gas yenyewe ni very poisonous gas, ni gas ambayo ina sumu, na wakati wa vita ya kwanza ya dunia mwaka 1916 this chlorine was used as the agent wakati wa kufanya maangamizi. Kwa hiyo ilitumika pia kama poison ambayo ilitumika ku kill people, ku harm a lot of properties. So this is the extremely very very poison. Tukisema extremely maana yake sana. Now it attacked the nasal and lungs membranes and eventual cause death. Kwamba yenyewe inashambulia kwenye lungs, kwenye mapafu, also the nasal part of the body. So ikiataki huko actually inapelekea death to the people. Now let us see how can we prepare this chlorine gas. Preparation of chlorine gas. Chlorine gas can be prepared in the laboratory by the oxidation of concentrated hydrochloric acid using oxidizing agents such as potassium permanganate, permanganese 4 oxide, also lead 4 oxide. Kumbe huyu chlorine anaweza kuwa prepared industrial, ambapo tunaweza tukamprepare laboratory. This gas can be prepared in the laboratory, lakini some of the oxidizing agents, those substances which will lead to the reduction method or reaction are involved, so as we can able to produce the chlorine gas. So enyewe ina involve oxidation. So the concentrated hydrochloric acid using those agents ambazo ndio kama hizo tumesema potassium permanganate, those strong oxidizing agents. Vile vile kuna manganese 4 oxide, lead 4 oxide. So these tend to be used so as to enhance the production or the preparation of chlorine gas in the laboratory. Now, when manganese 4 oxide and concentrated hydrochloric acid are used to prepare chlorine gas, gentle heating is required. We have to heat slowly, yani haihitaji haraka. So the gentle heat, slowly heating should be involved or should be required so as to attain the production or preparation of chlorine gas. Now, the setup for the laboratory preparation of chlorine gas is shown in the figure 1.3. We are going to see it in the figure which show the setup whereby the chlorine gas can be prepared in the laboratory. And actually, due to its nature of being poison in nature, so it requires the expensive mechanism, expensive setup. It requires the careful setup of the apparatuses so as we can able to conduct it without any harm to the surrounding or to the one which are required to the one which tend to prepare it. Now, the equation for the chemical reaction that take place is as follow, kwamba hii ndo reaction ambayo ina take place ili kuweza kumzalisha huyu chlorine gas. Kwamba we have manganese 4 oxide. This is manganese 4 oxide. Mean that here ilikuwa ni manganese 4. It means ilikuwa na valence ya 4. Lakini oxygen ilikuwa na valence au the charge of 2 electrons. So 4 and 2 means after multiplying each other we are going to have the 2. That's why here tumeandika hii chemical formula kama MnO2 ambayo hapa imeexist as a solid. Now it reacts with the concentrated hydrochloric acid which is made up of 4 molecules. Now we are going to have the chlorine gas as you see there. We are going to have a manganese chloride, but also we are going to liberate the moistures or this water molecule. And the setup is this one. This is a simple setup. This is our figure 1.3, which shows the setup of laboratory preparation of chlorine gas. So as you can see here, we have the round bottom conical flask. As you can see here, we have the concentrated hydrochloric acid is tend to enter through this funnel, ambapo hapa tuna ile tap. This tap, the main is to adjust, inatumika katika kuadjust. Wakati unafanya entering, unafanya pouring of your vol of this concentrated hydrochloric acid, unakuwa unaiminya hii hapa ili kuweza kumaintain kile kiwango ambacho kinaingia. Vile vile here we have the manganese 4 oxide. So here in the round bottom flask tuna our oxidizing agent, which is manganese 4 oxide. Now as you see here, it is in like this in solid state. Now here it tends to enter concentrated hydrochloric acid. So after reaction now of this, you can see there is a first conical flask, second conical flask, whereby this it involves the distilled water, ambapo tuliona kwamba kule kwenye reaction utakwenda kupata chlorine gas, vile vile tutakwenda kupata manganese chloride, as well as tutaenda kupata water. So this is distilled water, yale maji ambayo yanakuwa vapor, yanakuwa condensed humu. This is distilled water, this is water distillated, and this is two conical flask. I've said, unaona this test up imefungwa, imeunganishwa tena kwenye another conical flask, whereby this another conical flask is where the concentrated sulfuric acid is put, is kept here. But here the setup continue up to the gas jar. This is the gas jar. The main function of gas jar, my form for students, I hope you know it since you have studied the in Form 1. I think Form 1 you have studied the laboratory apparatuses and their function. You have learned on the gas jar apparatus. The main purpose is collection of data, gas, measuring the gas. So here in the gas jar is where we can collect our chlorine gas, as you can see here. This is the gas jar. Here it is closed at the top here, so no gas is except escaping, hamna gas ambayo inatoka nje, and here is where the chlorine gas obtained or collected here. Now this is just a simple setup of how the chlorine gas is prepared in the laboratory. Now, chlorine gas is passed through water in the first conical flask to remove any acid sprays and hydrogen chloride gas. Kwamba ya kwanza kabisa chlorine ina pass through the first conical flask. The aim is to remove any acid sprays and hydrogen chloride gases. So the concentrated sulfuric acid is in the second flask is for drying the chlorine gas. Kumbe tuliona pale tuna second flask, ambapo kwenye ile second flask conical flask tuliona kwamba kuna concentrated sulfuric acid. M ya pale ni ili for kufanywa drying, na baada ya kufanyia drying ndo pale ambapo tunaweza tukapata ile chlorine gas ambayo direct ile setup inaendelea, tuliona inaenda mpaka kwenye gas jar. Kwa hiyo ukifanywa drying pale is where the chlorine gas can be collected or can be formed at the gas jar. Now chlorine is denser than air and can be collected by the downward delivery method. Kwamba yenyewe ni denser than air. So if it is denser than air, mean that it involves the collection or can be prepared in the downward delivery method, kama tulivyoona pale. It is not collected over water because it is fairly soluble in water, forming yellow chlorine water. So chlorine yenyewe haijawa collected over water simply kwa sababu gani? Yenyewe ni soluble in water. So kama ni soluble in water, it means that it can react. So that's why we see the two setup of different conical flask, whereby the distilled water it found to their part, but also tumeona hydrochloric acid ilikuwa kivyake. So during preparation of chlorine gas, so we are not collecting it over water simply kwa sababu ni sobo kwenye maji. Kwa hiyo itahusisha reaction to take place and we will not get what we want. The required gas or chlorine gas will not be formed, while there will be the reaction taking place, the mechanism also the setup. Now the other method of preparing chlorine gas are similar to the one illustrated in the figure 1.3. This is the other methods. The main difference in the oxidizing agent used and the condition under which the reaction takes place, it is shown in the table 1.3. For instance, we have the potassium manganate. Potassium manganate is a very strong oxidizing agent, and when used instead of manganese 4 oxide, no heating is needed during the reaction. Kwamba potassium manganate yenyewe ni very strong oxidizing agent, so ikitumika instead of kutumia hii manganese 4 oxide, hata heating reaction or heating process is not required at all, kwa sababu yenyewe ni very oxidizing agent. Also, mixing manganese 4 oxide with sodium chloride is another convenient method of preparing chlorine gas. Kwamba tukichukua mixer ya manganese 4 oxide with sodium chloride, vile vile tunaenda ni njia mojawapo ambayo inashawishi au inapelekea formation of chlorine gas. Concentrated sulfuric acid is added instead of concentrated hydrochloric acid. Why and heating is required during this reaction? The mixture reacts to form respective metal, salt, water and chlorine gas. Kwamba concentrated sulfuric acid inakuwa added instead of concentrated. So the one used is concentrated sulfuric acid and not concentrated hydrochloric acid. Then heating is applied and finally required during the reaction, and the mixture reacted to form their respective salty, water and chlorine gas. This is the simple overall reaction which show those how this metal, salts and chlorine gas formed through these other ways of producing the chlorine gas. Now the overall equation for this reaction is as follows. Kwamba sodium chloride plus manganese 4 plus this sulfuric acid, kwamba tunatumia concentrated sulfuric acid and not hydrochloric acid. So after reacting this involving the heat, this delta, change in delta, this delta later, this mean that heat is applied. So ukiona hii kwenye mshale mean that there is heat applicable here. So we are going to have the manganese chloride plus sodium sulfuric sodium hydrogen sulfate plus water, but finally we are going to release the chlorine gas, which is what we need to prepare. C is chlorine can also be prepared by the action of dilute hydrochloric acid on calcium hypochlorite. Kwamba kumbe tunaweza tukatumia chlorine kumprepare chlorine by the action of dilute hydrochloric acid and calcium hypochlorite. Now this is calcium hypochlorite, as you see, ambayo on other word we know it is known as bleaching power, so it have the bleaching power. No heating is required, kwamba hapa hamna heat ambayo inakuwa involved. So calcium hypochlorite plus hydrochloric acid ambayo inakuwa ni diluted ina react. Baada ya kureact without the any heating, so we are going to have calcium chloride ambayo inakuwa ni aqueous. Vile vile we are going to have the water molecule, but finally we are going to prepare or to produce the chlorine gas. So we can prepare the chlorine gas through this action. We take the reaction between dilute hydrochloric acid with the hypochlorite compound kama unavyoona kwenye equation hapa. Now summary of the reagents and the conditions for preparing chlorine gas. These are conditions, these are reagents. Kwamba tukiwa na some of the reagent, the heat will be applied or not. The condition of no heating or heating is required will be or not. So once we have the reagent of manganese 4 oxide, this one, and the concentrated hydrochloric acid is where the heating is required. But potassium manganate and the concentrated hydrochloric acid, this no heating. Potassium permanganate is a very strong oxidizing agent, so this reaction takes place with no heating. So the conditions, no heating required during this reagent during the react so as to produce the chlorine gas. But also the mixture of manganese 4 oxide and the sodium chloride and the concentrated sulfuric acid. During this mixture, mchanganyiko wa hizi compounds wenyewe una involve the condition of heating. So the heating is required so as to involve the reaction to take place, and finally we are going to have the chlorine gas. But also we have the reagent of calcium hypochlorite and N-dilute mineral acid, ambayo dilute mineral acid ambayo inatumika hapa ni hydrochloric acid. So you can see that hypochlorite compound ikireact na N-dilute mineral acid ambayo for instance ni hydrochloric acid, the condition no heating is required, and finally we are going to produce the chlorine gas. Now my student, this marks the end of our session, but before I sum up our session, I would like to provide a task for you. The aim of this task is to ensure that you can have a trial. You can have a trial after passing through the session. It's better you can settle behind and trying to attempt this task so as you can widen and you can enhance your understanding. Now, the question is, with the idea of a diagram, describe how the chlorine gas can be manufactured in the laboratory. Involve the reactions taking place, kwamba make sure una consider the reaction taking place, but also elezea with the idea of diagram, mean that you will go through that setup of preparing the chlorine gas. Thank you so much for watching, my student. This marks the end of our session. Bye bye, have a nice time. But before I would like to remind you, don't forget to subscribe our Media Educare TZ, but also don't forget to like and comment. Also, don't forget to share this video toward your friends so as you can share the learning material. But also, I would like to advise you go through the different books, different past papers, so you can have a lot idea concerning this topic. My Form 4 student, I hope that you are the one you have to fight so as to achieve what you want. Thank you so much. See you in next session. Bye bye.